guys, today I would like to review theoretical probability. So let's just make sure that we understand our formula. So this is how we write the probability. So the probability of the event happening is equal to the number of favorable outcomes over the number of outcomes in the sample space. So on the top numerator, it's what we want to happen. And on the bottom denominator, it's all of the possible outcomes that could happen. All right, for our first example, a CD has 5 upbeat dance songs and 7 slow ballads. What is the probability that a randomly selected song is an upbeat dance song? Well, first, we need to figure out what our denominator is. What are the total outcomes in my sample space? So I have 5 upbeat songs, I have 7 slow ballads. So 5 plus 7 is 12. So 12 is the number of outcomes in my sample space. Those are total possibilities. All right. Our question is, what is the probability that a randomly selected song is an upbeat? Well, how many songs are upbeat? We have 5 songs, 5 upbeat dance songs. So 5 over 12 is our answer. Okay. Now, our next example, we are going to talk about number cubes. Okay, so I have a little chart over here. Okay. A red number cube and a blue number cube are rolled. If all numbers are equally likely, what is the probability that the sum is 10? Okay, so you are rolling a red number cube and you are rolling a blue number cube. So number cubes, their faces are 1 through 6. So if you imagine, let's see if I have a piece of paper. There we go. If you imagine that if we roll a 1 on the blue, all of the options for the second roll on my red could be 1 through 6. So 1 and 1, 1 and 2, 1 and 3, 1, 4, 1, 5, 1, 6. Okay. If you rolled a 2 on the blue, again, the red cube, you could get anywhere from 1 to 6. 3, same thing. 4, same thing. 5, same thing. And 6. Okay. So these are all of our options for rolling. Okay. Now, if you wanted to say, okay, well, what happens if I roll a red 1? So do you see the reds? 1, 1, 1, 1, 1. And the blues are 1, 2, 3, 4, 5, 6. Reds 2. Blue is 1, 2, 3, 4, 5, 6. Reds 3, reds 4, reds 5. So either way you look at it, these are all of the combinations that are possible. Okay. So first, we need to know what our sample space is. So instead of counting all of these little boxes, we know that they are both 6-sided. So 6 times 6, there are 36 outcomes possible. Okay? Now, that is my denominator number. Okay? So our question is, if all numbers are equally likely, what is the probability that the sum is 10? So here I want you to think about, okay, adding them up. Do any of these add to get 10? No. Do any of these add to get 10? Okay, so what I want you to think about are, okay, from 1 to 6, what are my numbers that add to get 10? What about 6 and 4? We have 5 and 5. We have 4 and 6. Now, this could be a red 6 and a blue 4. And this one could be a red 4 and a blue 6. So there are 3 of them. So 3 out of 36, and you can reduce that to 1 over 12. And that's our answer. Okay. Our next example Okay, we're still dealing with number cubes. So a red number cube and a blue number cube are rolled. If all numbers are equally likely, what is the probability of each event? Okay, so our first event, the sum is 6. So again, we have 2 number cubes, so I know my denominator, there's 36 possible outcomes. Okay, so the sum is 6. Think about 1 through 6, all of the numbers that add to get 6. You have 5 plus 1. You have 1 plus 5. You have 3 plus 3. You have 4 plus 2. And you have 2 plus 4. Okay? So that is 5 of them. So 5 over 36 is your answer for 1A. 1B, the difference is 6. Remember, difference means subtraction. So if my number cubes are 1 to 6, well, 6 minus 1 equals 5. So I can't get a difference that is 6. It cannot happen. Cannot happen. And when it's impossible, there's a 0 possibility. All right, our next one says the red cube is greater. All right, so I think it might be easier to go back here and look at the cubes. Okay, so we are looking for any time that the red would be greater. So if I look here, okay, red is greater when blues are 1, except for 1 over 1. Okay, so that's 5 of them. In the second row, when blue is 2, everything is greater except for what? 2 over 2, 1 over 2, 4. Okay, the third one, and we're going to continue to see which ones are greater. You're going to have 15 of them over 36, and you can reduce that to 5 over 12. Okay, all right. Now that we've talked about theoretical probability, I want to switch over to the complement. Okay, so the complement is not the chances of something happening, but the chances of it not happening. So our formula is 1 minus the probability of the event. So remember when we did our little chart, 0 was impossible and 1 was certain? Okay, so that's why we take 1 minus the probability of the event. All right, the game Battleship is played with 5 ships on a 100-hole grid. Players try to guess the locations of their opponent's ships and sink them. At the start of the game, what is the probability that the first shot misses all targets? So before we can find the complement, we actually have to find what the probability is of hitting a battleship. So again, we want to look at, okay, well, what are the total possibilities? Well, they tell us it's a 100-hole grid. So right off the bat, I know 100 is my denominator number, okay? And we have a chart over here with 5 ships. And the number of holes covered. So these ships, this was one of my favorite games when I was little. These ships are all different sizes. So the destroyer only covers 2 holes. The cruiser, 3. The submarine, 3. The battleship is 4 holes. And the carrier has 5 holes. Okay? So our question is, what is the probability of hitting one of these ships? So if I put all of these ships on my 100-hole grid, what's the possibility of hitting one? You're just going to add 2 plus 3 plus 3 plus 4 plus 5, okay? And we get 17. So 17 out of 100 means that's the probability of actually hitting one of these ships. The complement is well, what's the probability of not hitting a ship? So that's going to be 1 minus this. So instead of putting a 1, when I subtract fractions, I need the denominators to match. I'm going to change this to 100 over 100. 100 divided by 100 is still 1. Minus 17 over 100, and I get 83 over 100. Okay, so that is the probability of not hitting anything. All right, and we're going to do one more example. All right, two integers from 1 to 10 are randomly selected. The same number may be chosen twice. What is the probability that both numbers are less than 9? Okay, again, for our sample space, how many are possible? I have two integers from 1 to 10. Well, isn't 10 times 10 100? Okay, so I know 100 is my denominator. Now I want both numbers to be less than 9. Well, what numbers are less than 9 from 1 to 10? It's 1 to 8. So now there's only 8 options. So, and I'm picking 2, and they can be chosen twice. So 8 times 8 is my 64. Okay, and then you can reduce that by just dividing both by 4, and we get 16 over 25. Okay? All right, that's it for today. Good luck, guys.